Just for a laugh, I have decided to tackle the classic Skittle Sorter project. How hard could it be, right? The first step is to look at how it will work. I will look at using a carousel design. As the carousel rotates, a funnel will feed a Skittle into one of the 12 holes around the circumference of the carousel. As the Skittles enter the carousel, they rotate through a series of stations. The first of which contains an RGB color sensor that determines the Skittle's color. From there on, each of the stations has a gate system that allows the Skittle to drop at the correct exit tube. This means that there will be 3 basic design challenges. The first design challenge will be the entry station. This needs to have a hopper that contains the Skittles and must dispense Skittles one by one into the carousel. It will be okay if it occasionally leaves a chamber in the carousel empty, but it must not jam up, as this could damage the unit. The second station is the color sensing station and is a fully enclosed chamber that has an RGB color sensor above it. As the carousel rotates, the controller will keep track of the color in each chamber using this. I will probably make the carousel discs out of black PLA so that the RGB sensor can easily distinguish an empty chamber. It will also have the lowest effect on the readings. And finally, there are the exit stations. These will each correspond to a specific color, and the gate will open half a step before the Skittle reaches the station so that it can drop into a chute. There will actually be one more station type, the reject station. This is just an exit chute that drops any Skittles that are left over. If a Skittle is damaged and can't be matched to a color properly, this is where it will go. In this video, I am making a mock-up of the carousel. This is not the actual final carousel design, as there are still a lot of things to be tested and refined first. A stationary plate above the carousel will have only 2 holes in it. One will be for the entry station and the other will be for the color sensing station. This video shows the mock-up version of the top plate. The color sensing station is just an empty chamber with a PCB mounted over it, but I don't have any idea how the exit stations will work. So I will simply design a keyed slot that these will be fitted into as modules. This will allow experimentation in the future. These mock-ups represent the basic design parameters, so it's now time to look at the first design element, the entry station. The first part of the design consists of a funnel that a soft drink bottle will screw into. It should be possible to block the exit, fill the hopper, then unblock the bottom. The Skittles should then pour out evenly. Here is the test piece. It's pretty rough and it's held together with electrical tape. A hollowed bottle top is used to provide the thread. You will see that it blocks a fair bit. I may need to include a stirrer in the design to help keep them flowing freely. Instead of making an entire disc for testing, I decided to make a sliding block. This has an entry and an exit port and allows all of the dimensions to be tested. If it works correctly, sliding the block from one end to the other then back will eject one Skittle. So it looks like things are on track. The entry and ejection method is looking good, but the hopper system will need some work in the future. Now, to start designing. To start with, we need a support for testing. In the final design, I will probably use a 6mm threaded rod and 3D printed sleeves. Next, we have the bottom plate. You will note that this is similar to the concept design, but has only 10 positions. The top left hole is the reject slot. The top and top right are closed in for the entry and color sensor. The remaining slots are designed for clip-in gate modules. Also shown is a blank plate to test fit and a shim that goes between this plate and the rotor plate so that the two parts don't scrape. This is the rotor. The 5 cutouts and resets section are only there to conserve filament. There are 20 1mm holes around the outer edge. There is one for each chamber, as well as the gap between each chamber. These are for magnets. The hole through the center is 22mm in diameter and suits a 608 RS bearing. The shim, shown at the bottom right, goes under the bearing to ensure that the rotor turns freely without scraping. This is the top plate. The raised section allows some height for the entry tube to be fitted. Also, the color sensor will be raised as a result. Here is the post attached to the bottom plate using blue tack. Now to test fit the blank gate piece. It was awkward, but it fits perfectly. I did have to file it slightly though. Next, I'm fitting a shim so that the carousel won't scrape. Now the carousel plate with the 608 RS bearing press fitted. Next, a shim is fitted above the carousel to prevent scraping. And now the top plate is fitted. Finally, the entry tube is fitted and the carousel is given a test spin. Now to test the carousel. This is a close-up of the chamber where the color sensor would be fitted. Because the light is not good, I have used only orange, yellow and green Skittles. Red and purple ones were too hard to see. I used 3 of each colour for a total of 9 Skittles. Off camera, I repeated the test a number of times. It did not jam at all, though as expected, there were a number of occasions where I had to tap the hopper when the Skittles bottlenecked. Next is fitting the 20 magnets. Hall effect sensors are only sensitive to a particular pole, so I need to check that I'm holding the right end of the magnet. As the end of the magnet will be pressed into the rotor, it must be the end that doesn't trigger the sensor. Watch the blue LED. Now that I have the right end, it's time to push it into the hole. First, the hole must be re-drilled with a 1mm drill bit, as the hole is too small to be accurately printed. Double checking the magnet polarity. You can't see it because it's off camera, but the magnet is being inserted. The magnets stick together into a tube, so I'll handle them like a flexible rod and gently position the magnet, then push it in place. Now, testing the magnet against the Hall effect sensor. The Hall effect sensor has been soldered onto a Vero board and glued in place. Once the glue dries, I can fine-tune its position and hook it back up to an ESP32 to test that all the magnets are properly detected. Because the magnets are so tiny, they have to be precisely placed or the sensor will not pick them up. If there's too much float in the rotor, there may be problems with the magnets not being detected reliably. So let's give it a try. Again, watch the blue LED. As well as flashing the LED, it also increments a counter and sends the value out the serial port. I counted the magnets as I rotated the carousel and periodically checked the count to make sure it detected every magnet. After more than 500 counts, the result was still correct, not a single error. In the next video, I will fit and test the color sensor.